Students, good morning. Now I am going to derive an equation to estimate the total differential changes in enthalpy. This equation is much more helpful to us in estimating the differential changes in enthalpy for a single compressible substance or a single compressible fluid. Before entering into this discussion, let us recollect the fundamental property relations as well as Maxwell's relations. These two are much more helpful to us in deriving the total differential changes in enthalpy. First, enthalpy H is a function of temperature and pressure. Enthalpy H is assumed to be a function of temperature and pressure. If enthalpy H is assumed to be the function of temperature and pressure, then the total differential change in enthalpy is dH is equal to dou H divided by dou T at constant pressure into dt plus dou H divided by dou P at constant temperature in dP into dP. This is the main equation used to derive the total changes in enthalpy, total differential changes in enthalpy. We pretty well know that changes in enthalpy with respect to temperature dH by dt at constant pressure is nothing but Cp. Cp is the heat capacity at constant pressure condition. So dou H by dou T is equal to Cp into dt plus dou H divided by dou P at constant temperature in dP. Total differential changes in enthalpy. This is the main equation. Now I am going to replace this term by using fundamental property relations. Clear? By using fundamental property relations. The fundamental property relation dH is equal to T ds plus V into dP. Clear? Next, I am going to assume entropy S. This entropy S is the function of temperature and pressure. Entropy S is equal to the function of temperature and pressure. If entropy is the function of temperature and pressure, the total differential change in entropy ds is equal to dou S by dou T, at constant pressure into dt plus dou S by dou T at dou P at constant pressure into dP. Clear? Now ds is ready. I am going to substitute this ds into this equation. So total differential changes in enthalpy is equal to T times of dou S divided by dou T at constant pressure into dt plus dou S divided by dou P at constant temperature into dP plus V into dP. On separating this, T times of dou S divided by dou T at constant pressure into dt plus T times of dou S divided by dou P at constant temperature into dP plus V into dP. dP are common. Now I am going to rewrite this equation. Changes in enthalpy is equal to T times of dou S divided by dou T at constant pressure into dt plus T times of dou S divided by dou P at constant temperature, into dP. So dP common plus V into dP. Clear? So total differential changes in enthalpy is equal to T dou S by dou T at constant pressure in dT plus T times of dou S by dou P at constant temperature plus P into dP. Now I am going to equate this with this equation. Changes in enthalpy delta H is equal to Cp dt plus dou H divided by dou P at constant temperature into dP, equating the coefficients of dt and dP by equating the coefficients of dt and dP. Clear? Okay. T times of dou S by dou T at constant pressure is equal to Cp. This information provides Cp by T is equal to dou S by dou T at constant pressure. This is the important information. Once you know the value of Cp and temperature, it is easy to find out the changes in entropy with respect to temperature at constant pressure. This information is widely used in throttling process. Clear? Right. What next? What next? Dou H divided by dou P at constant temperature is equal to T times of dou S by dou P at constant temperature plus V. Clear? Now I am going to replace this. Okay. Now I am going to replace this dou S by dou P at constant temperature from Maxwell's relation. Instead of dou S by dou P at constant temperature, I am going to write dou V by dou T at constant pressure. Hence, differential changes in enthalpy dou H divided by dou P at constant temperature is equal to T times of dou V divided by dou T at constant pressure plus volume. Plus volume. This is the minus sign. Just I put this minus sign here. So change dou H by dou P at constant temperature is equal to V minus T times the dou V by dou T at constant pressure. Now I am going to substitute this information in this main equation. So dH is equal to Cp dt plus V minus T into dou V by dou T at constant pressure into dP. Clear? So this is the useful equation used to estimate the total differential changes in enthalpy. Total differential changes in enthalpy for a single compressible fluid. For a single compressible fluid. Clear? Thank you.